theme is Smart, Connected, Electric, Digital Playbook for Automotive Excellence. And there is no better place than Chennai, which is the hub of automotive engineering for India, but also becoming a great hub for global automotive industry. Close to 30% to 40% of manufacturing of cars and other automotive vehicles happens here. And it has a great presence in automotive R&D. In this seminar, we'll discuss a lot of strategies and mainly actions which we could take together in order to create impact. So in the next 20 minutes, I will be sharing my perspectives on a very key subject which is close to my heart, which is automotive engineering R&D. I think all the transformation which is happening in automotive industry, the epicenter starts with any R&D of a company. And I'll throw some perspective on the aspect of role of engineering R&D for the next automotive revolution. So I'll first start with my own small introduction. You have heard the term global capability centers. India is a hub of global capability centers or R&D centers. We have been telling in the past that it's R&D center. So how to establish a new R&D center or scale up existing GCC R&D center. Previously, before starting my own company, I was managing director of Renault Nissan Technology and Business Center based in Chennai, which is one of the largest auto OEM technical center in India with 10,000 plus people. It's one of its kind technical center. Right from concept to launch of the cars, this center is capable of. It is a global center for Indian cars as well as for global cars. I worked in this center for almost 18 years from scratch in 2008 to the center which is today. And before that I worked in General Motors, Case New Holland Tractors, Bajaj Auto, so all along in automotive OEMs. I had the privilege to work in Japan for conceiving a multi-purpose vehicle car for General Motors which was launched in India. And in between for 4 years I was also based in Europe heading Renault Technical Center. I have been fortunate to be part of CII South, Tamil Nadu CII South, and also part of NASCOM ER&D Council. So going forward, here you could see that I have been fortunate to launch many cars in India and abroad. So I'll try to bring my perspective of engineering R&D as I go through in the next 20 minutes. I'll give you a snapshot of the global engineering R&D. Global engineering R&D is currently at 2.5 trillion USD. It's very big and it is projected to grow at to 3.5 trillion USD. So almost similar to the GDP of India. So just to give you the size of the global engineering R&D. And in that big size of 2.5 trillion USD, engineering outsourcing, or we say R&D centers to put together is close to about 300 billion USD. And by 2030, this 2.5 trillion USD will grow to 3.5 trillion USD. And the global outsourcing of engineering activities will move to 700 billion USD. So you may wonder what is this double-digit growth which is happening, the massiveness of this engineering R&D globally, and it is driven by technology. And there are three things which is driving this. One is intelligent and connected products. Literally you see any product, whether it is a car or a washing machine or any appliances which we use, more and more it is getting connected, right? So it needs a lot of engineering efforts to make a product or a platform get connected. The second is mostly products are getting smart and intelligent, and behind that there is software and there is also AI coming in. So literally new platforms have to be made which is intelligent, compliant and connected. And the third big one, many of my colleagues here are from manufacturing background, smart manufacturing. So these three trends are really driving this huge R&D efforts across the globe. So where does India fall in? So in this 300 billion USD of pie of engineering R&D, India is today around 50. So you can see on the right hand side, 50 billion USD. Put together all the R&D centers we have, all the global capability centers we have is close to 50 and can grow to 100 billion USD market. So see the significance of engineering R&D and the role India plays in it. And if you see here, familiar suspects, what is growing? It is AI-led R&D. So AI will get into the process of developing a product, how to make the products faster, how to cut short the product development cycle. Physical AI, automation and smart manufacturing, right? Deep technologies, we talked about SDV and quantum, and also we have to mitigate the risk in terms of security and privacy. So all these are the drivers, and India is the place, already well established IT industry is there, with domain expertise of automotive exists, and how the domain experience and the AI experience and the IT experience of India can propel us to a $100 billion USD capability. So I think each one of us are part of this huge ramp up which is going to happen. So just to tell you what are the technologies which is driving this R&D revolution, you can say. First is SDX, software defined X. It could be software defined car, software defined manufacturing. It could be anything. And previously, I'm taking the context of the car. It was very mechanically driven mechanical development, where you put the steering, the brakes, the body in white, all put together, integrated, and then you make the car to be in motion, right? But now the car is, we have to make the car to think. So it will have cognition, it will have smartness, it has a connection to the cloud. So it's like moving from motion to emotion. The car is going to mimic you. The car is able to understand your behaviors and is able to replicate. So that's where software defined vehicle is currently happening in most of our cars. But I would say that slowly the car is also moving towards software AI driven vehicle. So the new kid in the block is AI driven cars, which is going to happen. The second big technology is green tech. Carbon neutrality is to be taken care, right? Zero carbon. And I think we have to reduce the tailpipe emissions. So of course electrification is a big part of it. But before we go into a fully electrified world, which needs the infrastructure, the bridge technology is hybrids. So hybrids is coming. Electrification is of course catching up. Today India is around 10 to 15% electrified. In scooters I think it is around 30%. In three-wheelers it is close to 80%. And we also have to take care of other technologies. So multi-fuel technology is going to stay for some time. You need CNG, you need LPG, you need hydrogen, hybrids and electrification and ICE will all coexist. And step by step we have to move towards a fully electrified, let's say, world. Third is secure design. So we have talked about design for manufacturing, design for quality, design for cost. But the new thing is design for security. So much of connections happening between the car and the cloud. You need to have the product secure and also take care of data privacy. So a lot of engineering has to be done in order to make the car secure and safe. Then AI/ML is playing a huge role. So AI will slowly get, and it's already happening by the way, getting embedded into the product development cycle. You have co-pilots with engineers generating the drawings. You have co-pilots doing the simulation, right? Testing, writing codes for you. So AI is getting embedded into the product development cycle. Benefit is you cut short the time to market and improve the quality. But also AI is getting into the product. The product is getting more intelligent and giving good customer experiences. Then digital twin. I think this is very, very important. It's no longer good to have, it's must to have. Is your virtualization of your physical entity. It could be a plant or it could be a product. So literally we do a digital twin. You can commission the plant on a digital scale, test all the scenarios and then go into a real plant implementation, manufacturing plant. Or you can cover all the scenarios which can happen in real life operation on a digital twin, prove out your product and then go to prototyping and to final production. So it's a big one. And the last but not the least, quantum is gaining momentum, because when you have to optimize with multiple parameters, quantum technology can really accelerate your optimization in order to bring out with stable and robust designs. So all these things are really contributing to the growth of engineering R&D. What we should do differently than what we are doing today? The three things which stands out is we are more and more going into a situation where we have to build platforms. The platforms, which is the mechanical side of the platform and the software, electrical and electronic architecture, which has to be scalable across multiple product lines. It has to be intelligent with AI embedded in it, and it should be able to have the SDV part so that you can configure and bring exciting features. So end-to-end capabilities is very important for R&D and scalable architecture. The second one, as I just mentioned, is AI across the development cycle. But when I say development cycle of a product, it is also the manufacturing side, where you make the digital replica of your plant and prove out everything, do virtual commissioning of all your equipments on the computer, and then you say, okay, now I'm ready, I have the optimized plant layout, now I can go for step-by-step industrialization. So this is what we have to do differently. It's already happening, but it will accelerate a lot. The traditional ways of car development or product development will be given way through these approaches, which will be very much different and will differentiate us. So is India in the right place? Is India the right place to do it? The answer is big yes, very big yes. And I need not tell to the audience, I think you are really aware, close to 1.3 to 1.6 million engineers are coming every year. So India is a skill, but also a scale. Then we are very cost competitive. Our costs are 1/3 of developed economies. So we can do the development of the car at almost 1/3 the cost of what it would happen in Europe, US and Japan. And even low cost countries like Eastern Europe, etc., we are half the cost. So we have the cost competitiveness, we have the skill and the scale, and then there is a huge network of global capability centers. Close to 1800 plus global capability centers exist, 200 premier academic institutions exist, and of course we have one of the largest pool of AI-enabled talent in the country. And not to say about ISIT operations, which has been for decades on the digital skills which possessed by India. So yes, the answer is big yes. And this is two charts which I like very much. I'll mention briefly. If you see on the left hand side, we are being compared with all the other countries like Romania, Eastern Europe and China, etc. What is thumbs up is in terms of engineering, infrastructure, in terms of digital infrastructure and in terms of talent. The left hand side chart says that you tick all the boxes, right? The closest to us is China, but I'll come to China in the next chart. In the right hand side chart, the y-axis is your capability index and the x-axis is your the readiness of your workforce. So you can see India and China cut from the rest of the countries in terms of engineering capabilities on the extreme top right? Now between India and China, what is the differentiator is the geopolitical risk. You can see China little black and India blue. That's the risk indicator. So India has the skill, scale, but India also has less geopolitical risk because we are not aligned to a particular block of countries, right? So there is an environment in which people feel safe and secure to work with Indian partners, right? So this is our advantage, this is advantage India. But is everything the green landscape nice, fairyland? No, I'm coming to that. What are the challenges? One thing, a famous slogan I would like to say, if we have to be in the top 3 in terms of engineering R&D in the world, we have to keep the Indian competitiveness, keeping the German precision quality and the Chinese speed. If we can master the quality, the speed and keep the competitiveness in India, this is the place to be. But what will make this success mantra, which I say success mantra, to happen? What does any enterprise would like to have from the R&D? So it's some sort of a summary of what I have been telling till now. We have to embed AI across the development cycle, right from making the first sketches of the car to drawing the CAD, the simulation, the software coding, the testing. Across the cycle, All the best countries in the world, especially China and US, have embedded AI, and we have to learn to work with AI up till the grassroots level. Second is, we need to have end-to-end capability to have the complete capability to have the chip design, the software in the chip, and to enable the features and services in the car. So system level ownership has to be there. You need to develop that. And I think the government of India is making a huge efforts to promote silicon and all that. Today we are heavily reliant on chips from outside and electrical electronics. We have to get this autonomy in terms of supply chain, but also in terms of capability. The third is the platform itself has to be scalable, connected and intelligent. That means software defined, AI defined, and also the hardware. The famous thing which I can see today happening is the car platforms are multi-fuel. In the same car, you have battery and the derivatives of electric cars. Then in the same platform, you have a hybrid option, and then you have the ICE option running. So this is the classic example in car where there is a scalable platform, and in that you put various technologies, and then you move. So it brings cost effectiveness, but also faster time to market, right? Then we have to make this platform secure, compliant and safe to meet the cyber security threats and all the privacy requirements which will come soon. It's already coming. And last but not the least, and there is another, the business side. More and more services will be in and around the car. Then a lot of personalization will happen. You select the services which suits to your own requirements. So personalization and hyper-personalization is going to happen. Then what will happen? You choose what you want. So there will be subscription-based feature development. So on the business side, more subscription-based product development has to happen. And you now know that with the car connected to the cloud, then you have the options just like you do in the TV channel. You pick and choose your TV channel based on your taste, right? You can pick and choose your services in order to suit your own requirements. So all these subscription-based business models are also coming. Now, in order to orchestrate all this, very important, which is extremely important, often disregarded, is talent management. We have to make sure that we are organized inside the company to break the silos and work together to make this system development, platform development happen. The days are very near where engineers and AI agents have to work together. And we have to completely restructure the way we organize, the way we think, and the way we work. So I think talent management is important, and also skill development is extremely important. Without the way we organize ourselves, the way we think, the way we imbibe AI into our day-to-day life, if it doesn't happen, all these technologies cannot be integrated into our lives. So you have to think a lot about the way we organize our talents. No auto OEM can do everything by themselves. So the mindset of the people have to change, that I not try to do everything by myself, because the lead time is huge. You skill up, then you get proficient, then you bring the technologies into the market. By the time the market has gone ahead. So you have to learn to collaborate with ecosystems, with your starters, with your suppliers, and co-create and co-innovate. On the other side, the partners also have to learn and evolve their models. You might have heard about time and material. Come on, give me 50 guys. I want in my R&D, I want to work. That has evolved into outcome based. So we say, no, we don't need people, we need outcome. But now the world is moving towards joint go-to-market. Means, okay, skin in the game. We are partners, we'll bring the technology in the car, we co-create and co-develop. So a big mindset change, the way we work has to happen to make this revolution happen. So in summary, I would say that this is where we are in the automotive industry. We have to, and the main growth drivers, as I said, is software-defined vehicle, and also embedding the AI in our development cycle, but also in the product to make it more intelligent. There is shift towards electrification, which we all know, and there is an emergence of new entrants and ecosystems. This is very interesting because maybe 20-30 years back, have you ever thought of working with Google and the Microsofts or the Qualcomms or the chip manufacturer? The answer is no. Automotive is a very closed world with you and your tier ones, the familiar suspects, Bosch, Continental, etc. And you conceive a car. No, now you have to work with the Googles and the Amazons and the chip manufacturers, the mobile service providers for the connection. So new entrants are coming, and this is a huge opportunity, I would say. What are the headwinds? Headwinds is that the way the electrification was supposed to happen is taking time because of infrastructure. So we still have to have bridge technologies like CNG, LPGs and hybrids. That's one. And second is there is a lot of spare capacity. Not in India. India is growing very fast, especially Europe and China, where a lot of investment is done, but the market is not growing. So there are some inventory challenges. But apart from these headwinds, which we can see, and also geopolitical risks, like most of the chips we are importing, then we'll have some restrictions of some countries like China and US that you cannot send this technology to these countries. So autonomy of the supply chain is becoming more and more important. So these are the headwinds which we are facing. And engine priorities, as I already said, electrification, SDV, manufacturing, smart manufacturing, integrating AI across the development cycle, across the business, and of course safety and security with AutoSAR and all the regulations on privacy which is coming. So I also tried my AI skills and to try to tell Gemini what is the automotive OEM's life, today's life and the life of next 10 years. So what you can see is in the center, the OEM is there. And then this OEM, of course, is connected to some traditional partners like tier 1 suppliers. You can see Bosch, Denso, Aptiv on the extreme top right. Then you can see that you need to have SDV. So you work with chip manufacturers like Qualcomm, NVIDIA, but also your cloud partners, Google, etc. Mobility service, because you have shared mobility, so you have to work with Uber. Maybe you need Spotify in the car. Then you have to make the car talk with the charging infrastructure, so then you have to work with the charging infrastructure players, which is on the bottom left. Car is connected, you have to have over-the-air updates of the software in the car. The car will never grow old, it's continuously getting refreshed. And then of course the data will be secured in the cloud. So imagine this orchestration which is happening. And does your traditional R&D has to survive this orchestration? So OEM cannot build the car alone, it has to orchestrate. And this needs change in mindset, change in the way we operate our R&D, the way we collaborate, and every engineer in R&D has to change their mindset, not to do everything by themselves, but to have a collaborative mindset. And even the suppliers have to change their mindset, co-create and co-develop, right? So this is my own hands-on experience on the journey. It's really happening as I speak. So I found this famous chart. It's one of my friend in LinkedIn, Augustine Friedel. The credit goes to him. He said that how the Chinese OEMs, the European OEMs, and the US OEMs are placed now. So on the rows, you can see all those, co-development partners, whether it is cloud or your operating system layer or the middleware, the central compute, the AI and agentic layer, and the battery suppliers. So I'll take 3 examples. The first one is the first one, BYD. You can see BYD has massive collaboration, but ownership also. They're literally owning everything, even if they partner. So, except for the cloud and data platform where they have partnership, they are owning the ADAS and the infotainment system. They are owning the middleware. They are owning the chip, central compute. They have their own AI models. And they are of course known for batteries, right? BYD started by being a battery manufacturer. Later on they become a car maker. So this is one model, China. So China is really moving faster than anybody in the world. They have mastered the complete value chain. Most of the Chinese suppliers are owning, right? Now the Europeans and the US guys are trying to catch up. So I give another example of a previous company, which is Renault, which is the red box. So here you can see that Renault owns the middleware, but it is trying to catch up by partnering with Google and Android system, which is Google based, for the operating systems. Then they're tying up for batteries with LG, Korea. And then the high performance compute is from Qualcomm, and the AI models again Google platform based. So this is a world of partnerships, and one has to live with it. But one thing is common, which is the horizontal axis. If you see the green box, the middleware, the operating system, still every OEM is owning it. Because ultimately the orchestration will happen, and we have to meet the brand requirements and the customer requirements. So you need that operating system and middleware to be in your control, right? Whereas all the others revolve around the middleware. So this is the nice picture I wanted to share, that how the auto industry is evolving. This is a very, so ecosystem play is key, and slowly the car is moving from software defined to AI driven car, step by step. Chinese is leading the game, others are following the Chinese. R&D is in the heart of automotive revolution. Please go back and look at your R&D operations. Are they working in silos first? Are they well integrated to all the actors inside the company? It should be open R&D. Second is R&D open to the outside world? Are they in a collaborative mindset? First starts with mindset, then the way we organize, and then this real magic will happen. Working with all the people which I have just mentioned in the previous slide, whether it is the chip manufacturer, cloud manufacturer, software defined partner, the tier ones and all. The success mantra, I say 3, catch up with Chinese speed. I think there is no way than to incorporate digitalization to its greatest extent. India is the place with so much talent on IT and AI. So I think we should be. But the way we organize and the mindset is also important to have the velocity. We are not known for good quality, unfortunately. We try to export a lot, but we are not known for quality. So I think technology is a great enabler, whether it's manufacturing or product design, to have quality in design, right at the design stage, whether it is process or product. And last but not the least, keep the Indian competitiveness, keep our frugal mindset, and this will be the game changer for us in the future. What are the stakes? As I said, can India go to catch the 100 billion USD market by 2030 in terms of engineering R&D? I think India is in a sweet spot, especially for automotive, to create a platform not only for India but for other emerging markets. Then India could design, manufacture and export automobiles to countries like Latin America, Asia Pacific and African countries. We can become the hub, but hub not only manufacturing but also design and development with scalable platforms. And last but not the least is, we are very poor in innovation. We are ranked 38 in the world in terms of innovation index. So our R&D spend is hardly 0.6% of global, of our gross domestic consumption, 0.6%. The global average is 1.8%. So we have to invest more in R&D. And the more we invest in R&D, the more innovation index will jump up. I hope that collectively we should be able to reach top 10 by 2030 or 2035. And execution levers, just to sum up, digitalization, AI being there and digital twins. Number 2, architecture and system engineering mindset to have scalable platforms. Ecosystem play extremely important, where OEMs, research labs, startups and academia work together. Have skin in the game with all of them to have joint go-to-market strategy. Indigenous supply chain, localized deep up to the chip level. I think government is doing a lot so that we master the entire value chain of a battery, of power electronics, or any technology you want to put in the car. And last but not the least, reorganize yourself, mobilize your resources well, skill them up at the right level, and be open to work with AI agents. With this, I conclude my perspective on auto engine R&D. Thank you very much for your attention.